So as we covered before, linear temporal logic is just a subset of the bigger branching temporal logic. This is branching, this is linear. Okay, now let's just go over an example, very similar to what you have in the homework. Let's say I have B and AX, EX this time, Q and R. Okay, maybe. This is randomly, I'm making this on the fly. Now you will need a structure like this because whenever you see A or E, you know that this will be branching and you need something that is branching like this. So when you look at this, if I have B here, this is S0. I'm looking at S0. You have to call something S0. I don't care if you call it S0 here or here. This is going to be your initial state. I don't want to say state, set, but you can think of it as a state. It's where your system is starting. So as you can see here, B is true in that initial state. That's very important. So if you call this S0, you have to put B here. Of course, it makes sense to just call the first set S0. So this is my S0, and I know B has to be true here, as per this. Okay, what else is true here? The remaining part. So all next exists next Q and R. What does this mean? It means that from here on, I can look one of these two ways. It means all next. All next. So this is the next one here. This is the next one here. All of them. If I had a third one here, I would count it because it's all of them. If this was E instead of A, then one of them would have been enough, right? If this was EX. But this is EX. So all of those next ones will be this. So this state as well as this state, just because those are the next ones, will have this expression exists next Q and R. Exists next Q and R. Okay, so now we are here. We have moved from here. We're done here. We're now here. Okay, just think about it. We're walking inside a maze or something. So we are here now. We're looking at these two branches. Exists next Q and R. So one of those doesn't have to be both. It could be both, by the way, but it doesn't have to. Exists one, so I'm just gonna maybe go with this one. What does this mean here again? Some people confuse this, and you think of this state here as X, Q, and R. Because it's E, so you go to one of them and you assign it whatever the next is, but that's not correct. Each step, you're looking at both of these at the same time. Okay, lots of people confuse this, so please take a moment to understand what's happening here and check with me if you're still confused. But I'm saying that one of the next ones, one of them, if this is A, then all of the next ones will be this. If this was EG, what is the difference? I'm not gonna say G here and all the next ones. No, it means the global ones starting from here. So this would be part of it, and the one before would be part of it. It's kinda confusing again, but each step in this branching structure, we're looking at a linear temporal aspect of it and a path identifier. Okay, so let's do this from the beginning. I know it's a bit confusing, so let's just do it from the beginning. I am now here. This is S1, for example, and I know that here I have this whole thing, E, X, Q, and R. So one of the next ones, either this one or this one, will be this. Let's just go with this one here, Q and R. Now that's all this says about that system. That's it. We're done. You don't need to keep going. Okay, but second branch also have the same because we had for all in the very beginning. So second branch, we also have exists next Q and R. So in my structure here, you can draw this in many different ways. You should probably have two branches, but here I only have one. So it says the next one, there exists a next one where this is true. So Q and R should be true here. And that's it. That's it for this question. Just try to remember that every time you're making a movement, you're looking at the path identifier, whether it's A or E, as well as some temporal logic expression, X, G, F, for example.